So let's discuss this problem which says find minimum time to reach last room. So basically we are given one matrix and we are at this location and we just need to reach here. So what are the constraints? So firstly we are given some entry time for each of the cells. For each of the cells we are given entry time which is basically mentioned here as move time. Move time is nothing but the entry time. But uh, we should be careful that entry time does not says that uh, at so suppose for this cell entry time is suppose x. So it does not say that at xth second or at xth unit time we can enter this cell. It just says that we actually can initiate to enter this cell, and for moving from one cell to another it takes 1 second. It takes 1 second. So it's a bit confusing in this question. uh, so we are given move time of I and j. So suppose this is the ith row and jth column, and move time, what it denotes, at what time we can actually start to move, not at what time we can gain entry. Move time is basically at what time we can start to move, and at what, and if we start moving at x time, at what point we will reach here, it's x plus 1. So this is a bit confusing, but this is what it means from this question. Now for each of the cells we are given move time, or the time at which you can start to move from the adjacent cell, and we need to figure out what is the minimum time through which basically if we start from here we can reach here. What is the minimum time actually, that we need to find out. Now how to solve this problem? So initially like this pattern suggests like moving starting from here and ending up to here, and we can move forward directionally. All these things actually suggest us that we need to solve it using uh, like we can if the limit is low we can go with recursion or DFS, and after that this seems pretty similar that it can be optimized using dynamic programming, isn't it? So let's see. So but let me just drop a hint. If you try to solve by DFS, you will get a timeout, and this cannot be done with DP. So again, this is a cross. So how we can solve this? So first, before solving this, let's look at the DFS solution. DFS will always give us the correct result, but even for the lower time limits, when n and m are within 50, that for Python also at least they are timing out. So let's first look at the DFS solution, and then we'll see like what's the correct approach for this. So this is a very simple DFS solution actually. So what we are doing is basically we are keeping one visited array, and uh, let's just forget about this. So this I was doing for top-down approach. Let's just forget about these two lines. Just let's just only concentrate on DFS. So firstly, we are seeing whether we already reached the bottom right corner, and if yes, we are just returning the current time. And next, we are having actually four directions that we can move: top, left, bottom, and right. And oh, okay, let's remove this. It doesn't make any sense. It's a redundant check. So first, we are marking visited for the cell as true, so that we do not revisit. And we are going over the next row and next column, and as mentioned in the question we can only move to the next cell if and only if the current time is actually greater than or equal to the move time, right? Or we need to wait, right? So as usual, we are uh, putting the entry time for the next cell as current plus 1 if move time is less equal current, or else we can only move when we reach the current time, right? Or you can only move when you reach the move time. So that's why here it's move time. So when you go to the next cell, the entry time will be either current plus 1 or move time plus 1 for that cell. And we are doing DFS and trying to find the best solution actually. So this gives us the correct result, no doubt. Now I was trying to solve it via uh, top-down approach, and that's why I created this dictionary. But if you try to hash these values, right, I, J, V, and current, it's very hard. Like the keys of the dictionary, like firstly we have V, like visitor array we are passing with it. We cannot hash this one. We can hash, but it's computationally very heavy. Like if you try to hash the whole visitor array along with IJ and current time. So that's why we are not able to add top-down approach of dynamic programming to it. And if you think about the bottom-up approach, I'm not able to get any solution. So, and if you apply this DFS approach, it is timing out even for lower limit as low as 50. So so what's the correct approach actually? So let's discuss the correct approach. After thinking for a while, like I actually struggled a bit and then came up with the BFS. So this is not exactly BFS. So this is a modified version of actually the Dijkstra algorithm. So with this visited array, what we are storing is basically what's the time uh, that we are able to reach on that particular cell. It's basically as simple as the Dijkstra algorithm. So firstly, we are setting the so this is basically current time, and these are the x and y coordinate as I mentioned here. So this is the current time, and this is the x coordinate, and this is the y coordinate. And we set the visited of I and j basically 0 comma 0 as 0 because we initially start from the top left corner. Now as in the Astra algorithm, first we pop these values and we see like whether we already reached, or basically the x and y coordinates are the right in the bottom right coordinates. Then we return the current time, or else we just loop over these directions to we just loop over this direction to get the possible direction that we can move actually. And again we apply the constant that's mentioned in the question. That's if move time that was mentioned, or the start to moving time, like when we can start to actually move into that cell is actually less than current time, then we set the next time as this, or else we wait and set the next time as move time plus 1 for that cell. And if we see that for that particular cell we are able to optimize it, then we put the cell in the mean heap, and we continue this loop. So this is the most optimized solution that I can actually think of, and it actually passed all the test cases. Thank you. And the so next we have a question for this contest, which says find minimum time to reach last room 2. Basically it's a variant of this question only. So let's discuss that question as well. Is that question actually the only difference is that you can move between adjacent cells, and the moving time is 1 2 1 2, like consecutively. First it's 1, then 2, then again, then 1, then 2, like this way will move. Previously it was 1 1 1 like this, but now it's this one. And also the n and m constants are increased up to 750. So let's discuss the solution. The solution of this is pretty much similar to the earlier solution. The only thing is in the min heap, um, in the elements of the min heap, we just added one more parameter, which is no, which is first 0, right? So basically, what happens, like it alternates between 0 and 1, where 0 means when you move to the next adjacent cells, if it is 0 for the current cell, the moving time is 1, and if the current cell, this value is 1 for the adjacent cell, the moving time is 2, as simple as that. So this is a very minor change, so we added this value, we are extracting this value, and we are adding plus 1. So first time it's 0 for, and so when you try to move to the adjacent cells, it will be, the moving time will be 1. Next time when we hit 1, it will be 1 plus 1, and we do percentile 2, so it's, so again we put 0. So that's how it continues. So there is a very minimalistic change between two questions actually, that is asked in this weekly contest, and these are the two solutions of two medium questions. Let's discuss the first question. This is a very basic question which says that we need to figure out whether a number string is balanced or not. So when it's balanced, so suppose we are given one number which is composed of n1, n2, n3, n4, n5, right? So we just need to add even positions and odd positions, and basically we need to first do summation of odd position and even position, and this, and if these two sum equals, then we say that's, it's a balanced string. Now how to approach this question? So this is a very easy solution, like we just keep on adding the odd positions, the even position, and if these two sum matches, then we return true, else false. As simple as that.